Assalamualaikum to Encik Asrun. My name is Nur Haitini binti Mardan and I'm Nurmalina binti Raza. We'll present about the digital mammography.
Okay, we go to the technology of digital mammography. For a long time ago, a firm scale mammography has been the gold standard for breast cancer detection. And in 2000, the digital mammography is introduced. It is the last modality to go digital. They're starting to spread throughout nations due to benefits of the technology. And about 30 to 35% of breast cancers are now using the digital mammography. So, what is actually mean by digital mammography? Digital mammography, also called whole field digital mammography, is a mammography system in which the X-ray film is replaced by the solid-state detector that convert the X-ray into the form of electrical signals. These electrical signals are then used to produce image of the breast that can be seen on the computer screen or also can be printed but on a special film similar to conventional mammogram. The computer-aided detector or CAD is also used to assist in the detection of breast lesions such as microcalcification like a lymph that present in the breast itself. So this is the digital mammography design. We have PC monitor, control panel, X-ray tube, field support, which is used to support the face of the patient and to at the same time to avoid the patient's head from entering the tube. And then we also have compression pedal to compress the breast at the optimum level so that the radiographer can get the best image. And we have also a amorphous selenium flat panel X-ray detector, like I said before. And then I will talk about the amorphous selenium plate detector. Digital mammography uses panels of electronic detectors for capturing the X-ray images of the breast as a collection of discrete electronic charges. And after the X-ray passes through the tissue undergoing imaging, it will encounter the layer of scintillator of the detector and convert the X-rays into the light form. Next, the light signals encounters the photodiode layer of detector where the signals are converted into electronic charges. Then these electronic charges are converted to signals of voltage and it is transferred to a monitor for display of image and to a computer for image storage and analysis. The digital mammogram is then stored on a monitor. And this is the workflow of the digital mammogram. The patients can have a bi-directional communication with the radiographer so that the radiographer has the right in order to correct the position of the patient.
For X-ray spectrum, which is produced by X-ray tube, it is determined by combination of three factors. The first one is the anode material or the target composition. The second one is the material used for X-ray beam filtration. And the third one is the kV or the power used. For mammography, usually we use 24 to 30 kVp depending on the breast size. I will move further into the target composition. As you can see in the slide right now, we can see that molybdenum has a Z number of 42. Thus, it will produce low Bremsstrahlung radiation, and the characteristic radiation produced is 19 keV. For rhodium, it has a bit larger Z number, which is 45, and larger Bremsstrahlung radiation than molybdenum, and the characteristic X-ray also larger. For tungsten, it is not usually used in for mammography because the Z number is very high. Okay, for molybdenum and radium, it can produce characteristic X-ray that is near to the optimum energy for mammography. Thus, both of the compositions usually used in the mammography, but not tungsten. For Bremsstrahlung, which is a continuous spectrum, it is more penetrating than the characteristic X-ray. And the effect of the high-energy Bremsstrahlung is that it will reduce the contrast of the mammogram produced, so it is not good for mammography. For molybdenum and molybdenum target, it is suitable for small breasts without extensive dense tissue because of its characteristic X-ray energy. For molybdenum and radium composition, radium composition, it may be used for more denser breasts because of its characteristic X-ray, which is bigger than molybdenum. Next, for the target design. Usually, a stationary anode is most common in the mammography machine, but then rotating anode or a bi-angle and double thread anode also be used in certain mammography machines. In mammography, we need to use a small focal spot size because we want to detect the microcalcification, and as we all know, small focal spot size will produce sharper image. So we won't miss any of the microcalcification. For the shape of the focal spot size, circular is preferred, but commonly found is rectangular. And to obtain adequate radiation, we applied the line focal spot principle and tilting the X-ray tube. Now we move on to the filtration. As we all know, filtration can be divided into two, which is inherent filtration and added filtration. I'll touch more about the inherent filtration first. As we all know, inherent filtration is the filtration that we cannot avoid, such as the window of the window of the X-ray tube. Usually the window of the X-ray tube is 0.1 mm aluminum equivalent, and the composition or the element that is usually used for window of the mammography machine is the first one, beryllium. Beryllium has a very low Z number, so it is suitable for mammography because mammography is using a low energy and we do not want too many radiation being attenuated. The second one is borosilicate glass. Borosilicate glass, we also use the thin borosilicate glass to ensure that not many radiation will be absorbed. Next, for the added filtration, we intentionally put a sheet of metal, which is tungsten or molybdenum, to absorb high energy of Bremsstrahlung or high energy of characteristic X-ray that exceed the optimum energy for mammography. For the mammography added filter, we often choose filter which has the same composition as the target, which is anode, because we want to allow more characteristic X-ray passes through and more high energy Bremsstrahlung radiation is absorbed. For the tungsten target, the filter that is often used is molybdenum or radium, and this will reduce the energy of Bremsstrahlung. The second one, for molybdenum target, molybdenum or rhodium filter is used to allow more characteristic X-ray passes through and even more Bremsstrahlung is absorbed. The third one, the rhodium target. The rhodium target, we will use rhodium filter as we want more characteristic X-ray passes through. As for the usage or the use of mammography, it is used for diagnostic or screening. Diagnostic is for the patient who have symptoms and a risk factor. And screening is for the patient who does not have any symptoms and does not have any risk factors, and etc.
Even though the digital mammography is highly expensive compared to the conventional mammography, but digital mammography provides a lot of benefits in the hospital here right now. Digital mammography improves contrast between dense and non-dense breast tissue. They also give faster image acquisition, which less than a minute, because there is no film to develop. In addition, the digital mammography will give the shorter time in examination. Thus, this will improve the patient comfort. And usually the time needed for the examination use digital mammography is half time less than the film-based mammography. And this digital mammography also provides easier image storage. Since the image is digitally stored, they can also be sent or transmitted electronically anywhere without loss of information. The storage space also reduced, as well as there are no more film room. The physician can also manipulate the breast image for more accurate detection of breast cancer. This is because with digital mammography, the brightness, orientation, contrast, and magnification of the image may be changed after the examination, and it helps the radiologist to view image of certain area more clearly. This digital mammography also has the ability to correct under or overexposure of film without having to repeat the mammogram. Okay, as we can see, this is the image of the breast which using the magnification of from the digital mammography. It will give the clear image in order to detect the cancer of the breast itself. So now we go to the differences between digital mammography and the conventional X-ray system. The first difference is the energy used. The digital mammography uses low energy compared to conventional X-ray system. Usually the digital mammography uses the kVp around 22 to 35 kVp, while the conventional X-ray system uses high, which is between 0 until maximum 100. And then the focal spot size of digital mammography is usually smaller than the conventional X-ray system. And then next is the target used in digital mammography and conventional X-ray system. The digital mammography uses a target of molybdenum, while the conventional X-ray system uses tungsten. Okay, the type that have in the digital mammography is usually floor mounted, but for conventional X-ray system, we can have both ceiling and floor mounted. Okay, the phantom used for digital mammography is the breast, while the conventional X-ray system is whole body. The image from a storage for digital mammography is stored, usually they're stored in the PC monitor, while the conventional X-ray system, the image are stored in the film cassette. So, as a conclusion, this digital mammography system is capable of producing an excellent image quality for a relatively low radiation dose with a high sensitivity to abnormalities. Thus, this will allow better breast cancer detection, especially in those women with radiographically dense breasts.